Hello, ma'am.
Good evening, sir. You can start,
Hello,
sir.
ma'am. Hello.
Good evening, sir.
Hello, ma'am.
Good evening, sir. Am I audible?
Yes, yes, ma'am.
Yeah, sir. You can continue,
Okay.
sir.
Good evening, sir.
1 minute. Ajay, good evening. 1 minute. Just give me some time. All right. Can you see the screen? Can you see the screen? Ajay?
Yes, sir. Yes, sir.
1 minute. All right. Now, what shall we do? We'll continue from yesterday, or we will do the derivation what we did yesterday and then continue. What shall we do? Ajay? Jaswant, you were there yesterday. Ritika was not there.
Sir, can you continue from yesterday, sir? Like from the beginning, sir.
From the beginning, you want me to do. Okay. All right. Now, we started with the graphical representation. For a first order reaction, rate constant of a first order reaction. Rate constant of a first order reaction. The formula is K is equal to 2.303 by T log of R naught by R. Or we can represent this equation also by K is equal to 2.303 by T log of A by A minus X. Both the ways. What is this R naught? R naught is nothing but A, that is nothing but initial concentration of the reactant. When we say initial concentration of the reactant, it is the concentration of the reactant at time t is equal to 0. No reaction has taken place. At time t is equal to 0, we call it as initial concentration. And what is this R? R is nothing but A minus X. It is concentration of the reactant after time t. After time t. This is the rate equation, time t. This is the rate equation for a first order reaction. These two representation, any one of these representation, but the NCERT says this representation. Now what we're talking about is, we're talking about the graphical representation of a first order reaction, graphical representation. Now, graphical representation of a first order reaction. Now, I can say that we know K is equal to 2.303 by T log to the base 10 of concentration of the reactant R naught, initial concentration by R. We know this is the rate equation. Now, what we can do is we can rearrange this equation. We can cross multiply T with K. When we cross multiply T with K, we get KT. You bring this 2.303 to denominator, you get 2.303. That will be equal to log of R naught minus R naught by R. So we learned that yesterday, KT by 2.303 will be equal to log of R naught minus log of R. Log A by B can be written as log A minus log B. So log R naught by R is written as log R naught minus log R. So now what is this log R? We want the value for log R. So if I take this value to the left-hand side, if I take this value to the left-hand side, you get KT by 2.303 minus log of R naught. And this minus R remains same. That is what I've written. So divide this equation by a negative sign. When you divide this equation by a negative sign, what we get? We get log R is equal to minus KT by 2.303 plus log of R naught. Log of R naught. This is in the format y is equal to mx plus c. This is in the format y is equal to mx plus c. This is the equation for a straight line in terms of what? Mathematics. So now when you plot a graph, that is log R versus time. If you plot a graph, we get a straight line like this. And slope, if you take for this straight line, the slope will be minus k by 2.303. See here, in this equation also, you can see from this equation, I'm just trying to get the color, different colors. All right. Okay, from the equation, you can see here. You can see minus k by 2.303. You can see this. This gives you what? The slope of the equation. So this is the graphical representation for the first order reaction, rate constant for a first order reaction. All right. Followed?
Yes, sir.
Yeah. Yesterday we did this, but anyways, to continue, have a continuity, we will do it. Now, the next is a derivation we did. That is, derive rate constant. Derive the rate constant for a first order reaction in gaseous phase. In gaseous phase. Now we learned in the previous equations what we used. This is all in aqueous state. This equation, what we learned, this is in aqueous state. Now we want it in gaseous state. Rate constant equation in gaseous state. Now we can say that consider a reaction. Consider reaction A giving you B plus C. Example, maybe we can say, yesterday I took an example, PCl5, when we heat, it decomposes to form PCl3 and Cl2. All are in gaseous state. All are in gaseous state. Here, A is also in gaseous state, B is in gaseous state, C is in gaseous state. A is a reactant, B and C are the products. Now we can write, let the initial pressure of the reactant. What is the reactant here? A. Reactant. B. PI. P stands for pressure and that I stands for the initial pressure. And we can write let X be the decrease in pressure. X be the decrease in pressure. What do you mean by X be the decrease in pressure? Now from PI, the decrease in pressure is X. That means there is a decrease in the pressure of what? The reactant. When there is a decrease in the pressure of the reactant, it means there is an increase in the product formation. So product formation increases, pressure also increases. When the decrease in the pressure of the reactant is X, it means the amount of products formed will also be what? X. How much ever pressure is decreasing, that much of pressure will be what? Formed. All right. So we can write now a tabular column, reactants and products. Reactants and products, or reactants and products. What are the reactants and product? A is a reactant, B and C are the products. Now this is the representation. Now what is the initial pressure? Initial pressure is Pi for the reactant. And what's the initial pressure for B and C? Is there any products formed? At time t is equal to 0, there is no B and C formed. Therefore, the initial pressure of B and C is what? 0. Following?
Yes, sir.
Decrease and or increase in pressure. Decrease or increase in pressure. What is the decrease in pressure of the reactant? Clearly, they say the decrease in pressure of the reactant is what? By X. When the pressure of the reactants decreases by X, it means pressure of the products increases by what unit? X. Now, what is the equilibrium pressure? The next is equilibrium pressure. Now, equilibrium pressure means pressure at equilibrium is called as equilibrium pressure. So pressure at equilibrium is Pi minus X, and this will be X, and this will be X. This is equilibrium pressure. Did you follow this so far? Now, what's total pressure now? Total pressure is represented by PT. Now, total pressure is given by the sum of the equilibrium pressures, Pi minus X plus X plus X. So this plus X and minus X will get cancelled. So total pressure will be equal to Pi plus X, or X will be equal to PT minus Pi. X will be equal to PT minus Pi. And I can write now, we know that K is equal to 2.303 by T log of A by A minus X. A is the initial concentration. So when I say A is the initial concentration, we can write in initial pressure also, we can write like 2.303 by T log of Pi. Initial pressure is Pi. A is the initial concentration, I told you. So this A is also Pi. And what is X? We found out X to be PT minus Pi, minus of PT minus Pi. So opening the brackets, you get 2.303 by T log of Pi minus divided by, this will be what? Minus PT, and this becomes plus Pi. So 2Pi minus PT. This is the rate constant of a first order reaction in gaseous state. Students, did you follow this?
Yes, sir.
Yeah. Is there any clarification, students? Can
No,
ask
sir.
others?
No, sir.
Any clarification? After a long time. Very nice. Ritika, good.
Yes, sir.
You followed? The derivations are there, and we can work problems based on the derivations a little later when we continue with the topic. Now, also students, for Ritika and Dhanalakshmi, few classes you missed, we were talking about something called as molecularity and order of the reaction. You can go through the other classes videos and you will know order, molecularity, and order of the reaction. So we have defined what is molecularity, we have defined what is order. And order is determined experimentally. Molecularity is determined theoretically by a balanced chemical equation. All right, you can just go through the concepts of molecularity and order in the other videos. You will understand better. Now, few questions we will solve and then continue with the topic possibly. All right, the first question is the rate of a reaction A plus B plus C giving you P is given by, rate of a reaction is defined as change in concentration with respect to time, and it is a minus sign because we know that concentration of the reactant will decrease. So minus change in concentration of A by dt is given as K into A to the power half, B to the power half, and C to the power 1 by 4. And they're asking the order of the reaction, the overall order of the reaction. The overall order of the reaction is given by the sum. See, order is defined as sum of the powers of the concentration terms in an experimentally determined rate equation. This is an experimentally determined rate equation. From this experimentally determined rate equation, sum of the powers, sum means addition. So 1 by 2, power of A is 1 by 2, order with respect to A is 1 by 2, order with respect to B is 1 by 2, and order with respect to C is 1 by 4. So sum of the powers of the concentration terms, when you add the powers of the concentration terms, it's all in fractions. Order can be a fraction also. So if you take LCM, you will get this value 5 by 4. The overall order of this reaction is option D, 5 by 4. Did you follow? So order is defined as sum of the powers of the concentration terms in an experimentally determined rate equation. All right. So there's complex problems which we have to learn based on order. This is so simple. All right. So we'll have to learn some of the complex problems a little later. We will learn. All right. The next question. Constant in case of a first order reaction is inversely proportional to concentration units, independent of concentration units, directly proportional to concentration units, or inversely proportional to the square of the concentration unit. Now, what is the rate constant of a first order reaction? Rate constant. What is the unit for rate constant of first order reaction? Anybody? Unit for rate constant of a first order reaction. Unit for the rate constant of a first order reaction is per time.
So time per
In
second, sir.
Per time, first time, or in per seconds. Now, when we come across this as per seconds, is there any unit corresponding to concentration here? Is there any unit corresponding to concentration here?
No, sir.
No. When there is no unit corresponding to concentration, we understand that this is independent of concentration. So if the first order rate constant is depending on concentration, you will have the unit also based on concentration, like mole per decimeter cube or mole per liter. But here you can clearly see from the unit of the first order reaction, the concentration term is not there. It means the rate constant is independent of the concentration units. Therefore, the answer for this question is option B. The next question. The rate law for a reaction A plus B giving you C plus D is given by the expression K into concentration of A. The square brackets indicates concentration of A. The rate of a reaction will be doubled on doubling the concentration. Okay. Now, what is this rate law? Rate law is equal to K into A. That is what they've given. Rate is equal to rate constant into A. That is what they've given. And now you can see from this equation, you can write the rate is directly proportional to concentration of A. So if concentration of A is increased, rate will increase. If the concentration of A is decreased, rate will decrease. That is what it means. The rate is directly proportional to A. Doubled on doubling the concentration of B. The rate law, there's nothing with respect to B. So this is the wrong option. The second option, you see, halved on reducing the concentration of A to half. That means when you reduce the concentration half, the rate of the reaction also will decreases half. Half on reducing the concentration of A to half, because rate is directly proportional to A. Hence, the answer for this question is option B. Followed?
Yes, sir.
Yes, sir.
The next question. When initial concentration of the reactant is doubled in a reaction, its half-life period is not affected. The order of the reaction is, we learned half-life period. What is half-life period? Half-life period is defined as time required for 50% completion of the reaction. Time required for 50% of completion of the reaction is called as half-life period. For a zero order reaction, we have derived this. So for a zero order reaction, half-life period is represented as T half. So half-life period is directly proportional to initial concentration. When we say half-life is directly proportional to initial concentration, just imagine when concentration increases, half-life period also will increase. because it is directly proportional. Now coming to the first order reaction, we have derived this relation. T half is equal to 0.693 by K. Now in this equation, for the first, this is the relation between rate constant and half-life period of a first order reaction. In this equation, is there any terms with respect to concentration? Is there a concentration? Is there any term
No,
with
sir.
respect to
No,
concentration?
sir.
No. That means half-life period is what? Independent of concentration. Is independent of initial concentration. Now, when I say half-life period is independent of initial concentration, whether you increase the concentration of the reactant or decrease the concentration of the reactant, what happens? Half-life period will not be affected. Because as per the equation, we understand half-life period is independent of initial concentration. So therefore, see the question, when initial concentration of the reactant is doubled in a reaction, its half-life period is not affected. The order of the reaction will be what? A first order reaction. Why? Because half-life period of the first order reaction is independent of initial concentration. It does not depend on the concentration. Therefore, we say it is a first order reaction. Followed?
Yes, sir.
Others? Just one.
Yes, sir.
Followed? Jaswant?
Yes, sir.
All right. Next question. Yeah. The rate of first order reaction is, see, the rate of first order reaction is 0.04 mole per liter per second. See, mole per liter per second. Concentration is that, time is the mole per liter per second at 10 seconds. And 0.03 mole per liter at 20 seconds after initiation of the reaction. The half-life period of the reaction is, they're asking half-life period of the reaction. You should remember, for a reaction, rate constant will remain same at any interval of time. For a reaction, the rate constant will remain same at any interval of time. That means for a particular reaction, whether you're measuring the rate constant at 10 seconds, or 20 seconds, or 30 seconds, or 1 minute, 1 hour, whatever time may be, the value K will remain what? Constant. Now, in this question, they have not given the rate constant. So, first part of the problem is to find the rate constant, because the question clearly says they're asking you to calculate the half-life period. And also, they have clearly told it is a first order reaction. So, for a first order reaction, how do we calculate the half-life period? T half is 0.693 by K. Now, we need to find rate constant. To find the rate constant, they have given the other values here. Now, what is the rate constant for a first order reaction? K is equal to 2.303 by T log to the base 10 of R naught by R. Now, what is time? 2.303. Time will be what? 20 minus 10. Change in time. See, final is 20 seconds, initial is 10 seconds. So 20 minus 10. Log to the base 10 of, what is R naught? R naught is 0.04 and R is 0.03. So that will be equal to 2.303 by 10 log to the base 10 of 4 by 3. So 4 by 3 can be written as log 4 minus log 3. So log 1 to 10 value you should know. Log 0 to log 1 to log 10 values you should memorize. So this will be on simplification, it will be 2.303 by 10 log 4 minus log to the base 10 of 3. So I vaguely remember it is 2.303 by 10. Log 4 is 0.6021 and log 3 is 0.4771. This is the value, I think. And simplification, you will get the answer to be 0.0287 per second. So rate constant value, what we get is 0.0287 per second. Now we have found out the rate constant here. Now, once we have done with the rate constant, we can find the half-life period. It's a direct substitution. So T half will be equal to 0.693 divided by 0.0287. So on simplification, we will get the answer to be 24.14 seconds. Half-life period, the unit is in seconds. So the answer will be 24.14 seconds. Did you understand this problem? So these kind of problems will be a regular POC question for 3 marks. Regular POC questions or 12th standard questions for 3 marks, 3 or 4 marks they can ask you. Okay, so I hope you followed with this. Yes?
Yes, sir. Yes, sir.
Yes. Now, if you followed with this, next question, I want some help from you. Kindly someone can help me the next problem. Read the question and tell me. A first order reaction has specific rate of 10 to the power minus 2 per second. Specific rate of 10 to the power minus 2 per second. How much time will it take for 20 grams of the reactant to reduce to 5 grams? How much time it will take for 20 grams of the reactant to reduce to 5 grams? Tell me, how do we work? It's a direct substitution. See the unit here. I say this unit is per second. It's a first order reaction. It's a first order reaction. For a first order reaction, what's the rate constant? The rate constant for a first order reaction is K is equal to 2.303 by T log of, we can write R naught by R. So what is given to you? They have given you the initial concentration. They have given us 20 grams, right? So we can write 2. They're asking you to calculate time. Rate constant they've given you. Specific rate, reaction rate means rate constant. So 10 to the power minus 2 is equal to 2.303 by T log of 20 by 5. So what will be T? T will be 2.303 by 10 to the power minus 2 log to the base 10 of log 4. Log 4. So T will be equal to 2.303 by 10 to the power minus 2 into log 4 is 0.06021. So on simplification, the answer we will get is 138.6 seconds. 138.6 seconds. All right. All right. Did you follow this? Now see this problem, we can work it in other ways. Alternatively, how can we work this? This particular problem we can work alternately. Now, since it is a first order reaction, we identified it to be a first order reaction. We identified it to be a first order reaction. Why? The unit says per second, it means it's a first order reaction. They have given you the rate constant for a first order reaction. So they've given you K as what? 10 to the power minus 2 per second. Now, since it's a first order reaction, is it possible for us to calculate the half-life period? What will be the half-life period? Tell me. Half-life period will be what? 0.693 by what? K. It will be 0.693 by 10 to the power minus 2. It will be 69.3. 69.3 seconds. 69.3 seconds. How that? Yes or no half-life period? Yes.
Yes, sir.
Now just see here. Initial concentration, how many grams they are taking as per the question? As per the question, the initial concentration is 20 grams. 20 grams. So this 20 grams we are taking. Now this 20 grams, to reduce it to 10 grams, the half-life period is how much? 69.3. Now from 10 grams to 5 grams, again it's a half-life period. It's again 69.3 seconds. So this is first half-life, this is second half-life. So totally 2 half-life period. So from 20 to 5, the time required to decrease the concentration from 20 grams to 5 grams will be equal to our total time will be equal to twice the half-life period. It will be 2 into 69.3. It will be again 138.6 seconds. It's all the same. Both you can see the answer is same. Whichever way it's comfortable for you, you can work. Follow this.
Yes, sir.
Yeah. Others?
Yes, sir.
Yes. Yeah, good. The next one. In a first order reaction, A giving you B. It's a first order reaction, A giving you B. If K is the rate constant and initial concentration, if K is the rate constant and initial concentration of the reactant A is 0.5 molar, then half-life period is. How the half-life period is related, they're asking. So in a first order reaction, it's a first order reaction. For a first order reaction, K is equal to 2.303 by T log to the base 10 of R naught, initial concentration by concentration after some time T. Or we can write this equation also in this fashion. K is equal to 2.303 by T log of A by A minus X. Now, half-life period, they're asking the half-life period, how it is related. So I can write T half at time T is equal to T half, X will be equal to A by 2. A is the initial concentration. 50% of the reaction would have completed. So 50% of A is what? A by 2. So T half will be equal to 2.303. I can take this K to the denominator, log of A by A minus A by 2. On simplification, we will get this 2.303 by T log to the base 10 of 2. Log to the base 10 of 2. Now, log to the base 10. Can I write this as natural log to the base log to the base e to the e2 divided by k? See, we learned it from natural log to log to the base 10. The conversion factor is 2.303. Now, in the option, if you see, these two are ruled out. It's wrong. But we know that they've given natural log here. So if we remove this 2.303, then we have to give natural log to the base 10. So natural log to the base e, natural log. So log to the natural log of 2 by k. So what will be the answer for this? The answer for this question is option D, natural log 2 by k. Followed? Students, are you following? Sir. Am I very fast or you're able to follow what I'm telling?
Sir, able to follow, sir.
Others, can you follow me?
Yes, sir.
Yeah. All right. The next question. The rate of gaseous reaction. The rate of gaseous reaction is given by the expression. Rate is given by the expression. We can write rate represented by small r is given by the expression k into e to the power 2 b into concentration of b to the power 3. This is the rate equation they've given. The volume of the reaction vessel is reduced to one of its initial volume. Volume of reaction vessel is reduced to one of the initial volume. What will be the reaction rate compared to the original rate A? So original rate, they say it is what? Now you people tell me, how do I work this problem? How do I work this problem? Now I see what's happening. Volume of the reaction vessel is reduced to 1/2. When volume is reduced to 1/2, what will happen to the pressure? What will happen to the pressure? What will happen to the pressure? What is Boyle's law?
Sure, it increases, the pressure is increased.
How much? When you decrease the volume by 50%, the pressure has to double or not?
Yes, sir.
So here also you see the volume is decreased by 50%. One of the volume is reduced. Therefore, concentration will be what? concentration will be what?
Doubled, sir.
Concentration will be doubled. So when this is, they say original rate, they say it to be what? A. That's what they've given here. Now, once the volume is reduced, what happens to the rate? This is the final rate. Now, in order to write the final rate, we can write K. See, concentration of A is doubled. So it will be what? Twice. 2 times. So 2 square. And again, concentration of B is also doubled. So I write 2 to the power 3. So what will I write? K into, this is 4 into, what is 2 cube? 2 cube is 8. So it will be how much? 32K or 32 times 32A. So initial rate is A, final rate is 32. So the time 32 times the rate of a reaction increases. Just by decreasing the volume by 50%, the speed of the reaction increases how many times? 32 times A. Here it is A and here it is 32. So there is an increase. This is 1A and this is 32A. So there's increase in rate by how many times? 32 times. Hence the answer for this question is option D. Followed with this?
Yes, sir.
The next question. Oh my God. Rate of formation of a dimer. What do you mean by dimer? Di stands for 2, mer stands for molecule. When 2 molecules combine, then the corresponding molecule formed is called as a dimer. The rate of formation of dimer in a second order dimerization, it's a second order, is 9.1 10 to the power minus 6 mole per liter per second at 0.01 mole per liter. Monomer concentration. What will be the rate constant? What will be the rate constant? So 2 molecules will react to give a dimer. This is A2. So rate of formation of dimer. What will be the rate of formation of a dimer? Rate of formation of a dimer will be equal to K into A to the power. This is the rate equation. Power has to be raised to the coefficient has to be raised to the power. So what will be K here? K will be the rate of, see from this equation we are deriving what is K. So we can write K as the rate of formation of a dimer by concentration of the reactant A square. So what they've given, formation of a dimer in a second order dimerization, they've given as 9.1 into 10 to the power minus 6 mole per liter per second. And what is the concentration they've given? That is 0.01 mole per liter, the whole square. 2 times. A square there, 2 times. So on simplifying, we will get the answer to be 9.1 into 10 to the power minus 2 liter per mole per second. You can simplify. It's a simple mathematics. You simplify, you will get 9.1 into 10 to the power minus 2 liter per mole per second. Did you follow this?
Yes, sir.
Yeah. Any clarification with this?
No, sir.
Girls, others? Any clarifications?
No, sir.
This WhatsApp. All right, the next question. The rate constant for the reaction, nitrogen pentoxide giving you nitrogen dioxide plus oxygen is 2 into 10 to the power minus 5 per second. 10 to the power minus 5 per second. Rate constant is K, 2 into 10 to the power minus 5 per second. If the rate of a reaction is rate of a reaction is 1.4 into 10 to the power minus 5 mole per liter per second. What is the concentration of N2O5 in mole per liter? They're asking what is the concentration of N2O5. Now, as per the reaction, we can write rate is equal to K into concentration of N2O5. Correct? Concentration of N2O5. Now, concentration of N2O5 will be what? Rate by K. So rate they've given us 1.4 into 10 to the power minus 5. Rate constant is 2 into 10 to the power minus 5. On simplification, the answer what we will get is 0.7 mole per liter. It's a simple mathematics. This will get cancelled. It's 2 times, 1 by, it's 0.7. Simplify. So the answer for this question is option B, 0.7. Students, you followed with this. See, you have to work, you try to work from any other material if it is available from your side, or practice the similar questions again and again. Only then you can remember. All right. If you don't put an effort, you will forget easily. So kindly keep working, keep focus and work, or start learning the chapters, what's already there, the videos you keep repeatedly watching so that you can understand. Crackers, yesterday it was early, now almost finishing the class. Which of the following is an example for fractional order reaction? Fractional order reaction, order can be fraction also. And we told that order is determined experimentally. This acetaldehyde will decompose to give methane and carbon monoxide. This is the reaction. Now rate, when you determine experimentally, rate is equal to K into CH3 acetaldehyde concentration to the power 3 by 2. Order with respect to this reaction is a fractional reaction, 3 by 2. So they're asking which of the following reaction is an example for a fractional order reaction. So this is an example for a fractional order reaction. CH3, CH4 giving you CH4 and CO. Remember this. And also we have one more example for a fractional order reaction. I am just give me a second. Give me a second. Let me see if I can give you one more example for a fractional order reaction. Fractional order reactions not there. Where it is? Yeah. One more example is formation of hydrogen bromide. Example 2. This also you remember, formation of hydrogen bromide. Hydrogen and bromine gives you 2HBr. This is the reaction, hydrogen bromide. So the rate of this reaction will be equal to K into concentration of hydrogen and into concentration of bromine. Okay, when you determine the order experimentally, the order with respect to hydrogen is 1, the order with respect to bromine is half. So therefore, the overall order of this reaction is 1 plus 1 by 2, it is 3 by 2, or it is 1.5. Here also it's 1.5, here also it is 1.5. These two examples you should remember. One is decomposition of acetaldehyde, the other one is photochemical combination of hydrogen and bromine. So photochemical combination of hydrogen and bromine. So photochemical combination means this happens only in the presence of sunlight. So this is also an example for a fractional order reaction. The next question. What will be the, what will be the rate equation for the reaction 2x plus y, giving you Z, if the order of the reaction is 0. If the order of the reaction is 0. Now, if you observe this equation, we can write the rate of the reaction is equal to K into concentration of X to the power 2 into concentration of Y to the power 2, Y to the power 1, as per the equation. But they say the order with respect to the reaction is 0. When the order with respect to the reaction is 0, what happens? Anything to the power 0 is what? Anything to the power 0 is what?
So what?
So what happens? Rate becomes equal to rate constant. So X to the power 0 becomes 1, Y to the power 0. See, this is theoretically. Theoretically, as per the balanced equation we wrote, as per the given equation. But they have given clearly the order of the reaction is 0. So that means the concentration to the power should be what? 0. When you take 0, then the rate becomes equal to rate constant. Answer for this question will be option B. Following?
Yes, sir.
Yeah. The next question. For a reaction I minus plus OCl minus, giving you IO minus and Cl minus in a medium, the rate of reaction is given by. The rate of reaction is given by. As for change in concentration of IO minus with respect to dt is K into concentration of I minus into OCl minus minus. The overall order of the reaction. What is the overall order of the reaction? Now, looking at the equation, the overall order of the reaction, order with respect to I minus will be what? 1. Order with respect to OCl minus is again 1. And this OI minus or IO minus, it's not OH minus. It's this OI minus. OI minus. This is also order is 1. So therefore, the net order of the reaction will be 1 plus 1 minus 1. Denominator we have 1. So if we go to the numerator, it will become minus 1. So the net order of the reaction will be 1. So answer will be option C. It's a first order reaction. It's a first order reaction. Now, next, clarification, students. We are doing a lot of problems today. A lot of theory also is left out. Next class, we'll do some theory. Few more problems we'll work today. For a reaction N2 plus 3H2 giving you 2NH3. If the change in concentration of ammonia with respect to time is 2 in 10 to the power minus 4 mole per liter, the value of change in hydrogen with respect to time they're asking. This is the first class what we learned in this chapter. How do I write the stoichiometrical rate equation for this? Minus change in concentration of nitrogen with respect to time dt will be equal to minus change in concentration of hydrogen with respect to time. Since the coefficient is 3, we have to divide it by 3. Therefore, write it as 1 by 3. Since these two are reactants, we write it as minus sign. And here, product, ammonia formation, it's a product with respect to time. Since the coefficient is 2, we write it as 1 by 2. And I write it as a plus sign because it's a product form. This is the stoichiometrical rate equation. See what they have given. They have given the formation of ammonia 2 to the power minus 4. And they're asking you to calculate the change in concentration of hydrogen. So we can equate these two equations. When we equate these two equations, we can write it as minus 1 by 3 change in concentration of hydrogen with respect to time is equal to plus 1 by 2 change in concentration of ammonia with respect to time. So we can write this as minus change in concentration of hydrogen with respect to time. Cross multiply this 3. You can write 3 by 2 change in concentration of ammonia with respect to time. So equal to what? 3 by 2 into, what is the concentration of ammonia they've given? 2 into 10 to the power minus 4. On simplification, we'll get 3 into 10 to the power minus 4 mole per liter per second. So the answer for this question will be option A. Did you follow this?
Yes, sir.
Firstly, you should know how to write the stoichiometrical rate equation. Once you understand how to write the stoichiometrical rate equation, then you can calculate it. Now, similarly, can you calculate what will be the change in concentration for the formation of decomposition of nitrogen? So if at all, instead of this, if I would have asked you N2, what you would have done? You would have equated these two equations. Yes or no?
Yes, sir.
Students, are you following?
Yes, sir.
So next question. Where is that question? In a reaction, A plus B giving you product, rate is doubled. When the concentration of B is doubled and rate increases by the factor 8, when the concentration of both the reactants A and B are doubled, the rate law of the reaction can be written as, the rate law of the reaction can be written as. It is a very lengthy problem. It's a very lengthy problem. Okay, we'll finish off with this problem. I don't know whether I have space to write. Space is a problem. Space is a problem. Okay, we'll try to finish. Now, as per the reaction, we can write a rate is equal to K into concentration of A to the power X into concentration of B to the power Y. See, order is X and Y. See, reactants are A and B. So therefore, order is X and Y. We'll mark this as what? Equation 1. When the concentration of B is doubled, when the question says, when the concentration of B is doubled, when the concentration of the B is doubled, rate of the reaction is also doubled. Rate of the reaction, rate is doubled, they say here. Rate is doubled when the concentration of B is doubled. The rate also doubles. When we say rate also doubles, we can write R1. This is R. We can write as R1 is equal to K into concentration of A to the power X into constant 2B. Concentration of B is doubled. Y, that is equal to 2R. We will write it as 2R. This will write as R1 and this we will write it as R1 and that is 2R. This will mark it as equation number. The third factor is if the concentration of both the reactants are doubled. If concentration of both A and B is doubled, the rate increases by how many times? Rate increases by the factor 8, they say. So we can write R2 is equal to K into 2A to the power X into 2B to the power Y. That will be equal to 8R. 8R, 8 times the reaction double. This will mark it as equation number 3. So we can write this as K into 2X, 2Y. 2X and 2Y, you can take it as common factor. And we can write it as A to the power X and we can write B to the power Y. This we can mark it as equation number 4. Dividing equation 2 by equation 1. Dividing equation 2 by 1. When you divide equation 2 by 1, what do I get? 2R by R. 2R by R will give you A to the power X into 2B to the power Y divided by A to the power X into B to the power Y. So that will be equal to what? 2 will be equal to 2 to the power Y. All this will get cancelled. This also will get cancelled. 2 will be equal to, here also see B will get cancelled. 2 to the power Y. So, or you can write 2 to the power 1 is equal to 2 to the power y, or we can write y is equal to 1. So we have found out the order with respect to y. Now, similarly, dividing equation 4 by 1, dividing equation 4 by 1, dividing equation 4 by 1, what we get? 8r, 4 is 8r, 8r by r is equal to 2 to the power x, 2 to the power y into a to the power x into b to the power y divided by a to the power x into b to the power y. So on simplification, 8 will be equal to 2 to the power x and 2 to the power y. So we know that y is equal to 1. Since y is equal to 1, we can write 8 is equal to 2 to the power x into 2. So 4 will be equal to 2 to the power x. So x will be equal to 2. So what will be the overall order of the reaction? Rate will be a to the power k into a to the power x, not 2 into y to the power 1. So the answer for this question will be option D. K is equal to a to the power 2 into b to the power 1. This is B, not Y. Sorry, this is B. Please go through this problem. It's a lengthy problem. Just go through and see if you have followed. Otherwise, you can ask me. We can clarify. Students, are you there?
Yes, sir.
Please clarify if anybody has any doubts. Students, anybody? Others, Dhanlakshmi and nobody is talking?
Sir?
In clarification?
No, sir.
No.
I
Lie
have
or
to watch
truly?
old videos, sir. Sir, I have to
Huh?
watch old videos, sir. I have to watch old
yes,
videos.
yes. Yeah, I understand. I got it. Yashwant and others? All
Yes, sir.
right.
Follows.
All right. If you have understood, we'll continue the class in the next session. Ma'am, I'll stop the class, ma'am.
Yes, sir. Thank you, sir.
Thank you. Bye.
Thanks, sir.
Bye, everybody. Bye. Bye.